Okay, gentlemen, we're jumping into 4.2. So have that handout out, and here we go. We're going to jump right in. Find the equation of the line through negative 3, 7, and perpendicular to the line 2x plus 3y minus 9 equals 0. Well, if it's perpendicular to this line, we really want to know what the slope is, because the negative reciprocal slope would be the perpendicular slope. But just by looking at it, you can't see that. So let's first convert to y equal mx plus b. This handout in its completed version is on Edsby, and it'll be a lot neater because I was using my iPad for that version. So if you want to see that clean, neat version, check that out there. So we start off with 2x plus 3y minus 9 equals 0. We're going to leave the 3y where it is. We're going to send this 2x over and the negative 9 over as well. So I'll have negative 2x and a plus 9 because they switch teams, change jerseys. And then we divide everything by 3. In this case, we end up with negative 2/3 x, and then 9 divided by 3 is 3. But again, we're not too concerned with that. We just really want to get this slope. So I know the slope is negative 2/3, but the perpendicular slope is positive 3/2. That's what I'm looking for. So now I know y equal 3/2x plus b, because we're finding the equation of a line through negative 3, 7 that's perpendicular to the line we just converted. So we got its slope, we found the negative reciprocal slope, and now we need to find out where that line will meet the y-axis for its y-intercept. Remember, if I have a slope of 3/2, let's pretend that the line goes through 0, 0 for a second. The slope would tell me to go up 3. My greatest there. 1, 2, 3, and right 2. 1, 2. There would be another coordinate. Or if I want to draw a line, draw a dot the other way, I can also think of it this way. Negative 3 divided by negative 2 is the same thing as saying positive 3 over positive 2. So technically we can go down 3 and left 2, but we're on the same line. So that's my line. But there are an infinite number of lines that have a slope of 3/2. I can keep drawing these forever. But there's only one of them that goes through the point negative 3 and positive 7, which is probably somewhere up there, right? But the y-intercept would be way up there as well. That's where that line is going to hit. If that's negative 3, 7, that's where that line is going to hit the y-intercept. So we're going to use that coordinate algebraically to find out where our y-intercept is. Let me erase this as well. So communicate what you're doing, sub in negative 3, 7, and I get 7 for y equal 3/2 negative 3 plus b, 7 equal negative 9/2 plus b. I know some of you are still making the error that when you multiply a whole number times a fraction, you're giving it to the numerator and the denominator. But remember, negative 3 is really negative 3/1. It's numerator times numerator, denominator times denominator. Okay. Now we bring the negative 9/2 to the left, and we get plus 9/2 equal b. We need a common denominator, which is 2. So it's 14/2 plus 9/2 equal b. And that's 23/2 equal b. So therefore, our equation is y equal 3/2 x plus 23/2. Not the nicest fraction to have to deal with. Keep in mind also, when you're writing the x next to the slope, that x must be in the middle with the dividing line, right? It's not, some guys, sometimes you'll do this, 3/2, and you write the x. That would look like a denominator. So be careful on your math form to be neat, clean, and organized there. And that's our equation. Okay, so that's one part of the answer. That's our slope y-intercept form. So our y equal 3/2x plus 23/2. To convert it to standard form, which is really ax plus by plus c equals 0, there's two rules. One is no fractions. And the second rule is a has to equal positive. So the first thing is, how do we get rid of the fractions? Well, the easiest way is to actually multiply everything by the lowest common denominator. In this case, it's 2. So we're really going to multiply every single term on both sides by 2. When I multiply by 2 here, I get 2y equal, and here we can cross reduce. That 2 cancels out the other 2 that's being multiplied. So we'll opposite operation, right? You're dividing by 2, then you multiply by 2. So it cancels it out. So we're left with 2y equal 3x. And 23 over 2 times 2, that cancels out as well. I'm left with just plus 23. Okay. Now, the a value is the boss. The a value right now is 3, and it's positive right there. Well, if it's positive, I'm going to leave it where it is. 3x stays there. The 2y is going to come join, becomes minus 2y. The positive 23 was already there. Now, I could write equal, I can write the equal 0 here, or I can write it on the right. I'm going to write it on the right because we want it to look like ax plus by plus c equals 0. So there you go. We end up with 3x minus 2y plus 23 equals 0. All right, there's my kids in the background. All right, so we've got this relation. Here are the key concepts. This is right from the textbook, 4.2. A couple of things to notice. In grade 9, we learned that the standard form, we just did ax plus by plus c equals 0, is the standard form of a linear equation. But for a quadratic, this is going to come up very often in chapters 4, 5, and 6. The standard version of a quadratic is ax squared plus bx plus c. Notice how it's a second degree equation because it has an exponent 2, whereas in grade 9 we have y equal mx plus b, and there's an invisible 1 on the x. That's a first degree equation. Okay, remember, you can classify equations based on the degree and the number of terms, like for example trinomial, binomial, etc. And the graph of a quadratic is parabolic in shape. We call this a parabola. Okay, this one opens down, one of them opens up. And the vertex, which is pretty much where it bottoms out. And it can bottom out or peak. That's your vertex. Okay, peaks or bottoms out. It's either the minimum point of the parabola or it's the maximum. Again, depending whether it peaks or whether it troughs, right? A parabola is symmetrical. You've seen parabolas in construction in BC Place downtown. You see them at the CNE on the Canadian National Exhibition Grounds. The Dufferin Gates has a parabola at the entrance there, lit up, and it's symmetrical. You know, when you're in elementary school, you used a mirror to try and draw the other side of something and draw it perfectly symmetrical. Well, there's one line of symmetry. What we're going to be getting into is this line of symmetry, the axis of symmetry. Remember, in grade 9, we had a special case. When you have a vertical line written like this, for example, right here, we'll say that passes through 3 on the x-axis. The equation for that line is x equal 3. Just like a line running through positive 3 on the y would be called y equal 3, because y is always 3 on that point. Whereas here, x is always 3 anywhere on that red line. Okay. So a vertical line also has an undefined slope. Remember that? So x equal 3 is always the equation of a vertical line. So whenever a question asks you what the axis of symmetry is, your answer is always going to be x equal blank. Okay. All right. The thing we're going to focus on right now is if a relation is quadratic, the second differences are constant, but the first differences are not. And we looked at this in past handouts where you have a table of values. And I talked to you about this with figure numbers, etc. If you, every time you go over 1 on the x-axis, if you go up 3 on the y, over 1, up 3, over 1, up 3, you get this linear pattern. That's a linear relation because the first differences are constant. You're constantly going up 3 every time x goes over 1. So it's linear. Whereas with quadratic, it's not true. It's exponential. The exponent 2 creates this, what looks like acceleration or this curve pattern, nonlinear pattern. So let's take a look at these together. We have x is 5, y is 4. The first differences are right here. From 4 to 2, we went down 2. From 2 to 0, we went down 2. From 0 to -2 is down 2. And -2 to -4 is down 2. So we could say that this is definitely linear because the first differences are constant. Every time x goes down 1, the y values also go down 2 consistently. Whereas in this example, you'll notice something different. From 1 to -2, we go down 3. From -2 to -1, we're actually going up 1. From -1 to +4, we went up 5. And from 4 to 13, we went up 9. Now we can look at the differences again. From -3 to +1 is up 4. From 1 to 5, up 4. From 5 to 9, up 4. So now our second differences are constant. So this we could say is quadratic. And the graph of a quadratic equation is a parabola. The graph of a quadratic equation is parabola, or you could say is parabolic in shape. Now I went ahead and graphed this below, but what I thought would be a good idea right now is to take out your GDC, reset it if you like, or try and go into your stat menu, edit, and I'd like you to try and see if you can graph that. Oops, not sure what happened there. I want to see if you can graph that on your GDC and see if you can get the right the same parabola that I get when I graph it manually. And then do your own scatter plot, a speed versus stopping distance, and see if you can come up with the right answer. I'm just going to tab that down for a second. And we'll have our graph. So here's the graph of it, what I came up with. And what I'd like you to do is use your GDC or your graph, and I want you to see where this goes. Does that go to 0? Does it go here? Does it go there? And try and tell me where that ends up. I actually made a mistake on the handle, the answer key that's on Edsby in our classroom library, and I'm gonna have to edit that. So you tell me, where does that line go? Where's its y-intercept? All right, and we'll see you in class on Monday. Have a blessed week. Take care.